So I would say let's start. Hi everyone, also a very warm welcome from our side to the AWS Summit here in Berlin. This is ARC202. My name is Stefan Schiller. I'm a solutions architect at AWS. I work in the cloud industry for the past 5-ish years now, worked for different cloud providers, mainly focusing on serverless technology and streaming platforms. And with me here on stage is Dennis Turkov. He's the Vice President of Architecture from Spryker Systems. And he's also mentoring software architects, technical leaders in the cloud industry, evangelizing on the developer experience in the cloud. And I'm very happy that he's with me here on stage. And together, we will talk about architecting a global multi-tenant application composition platform. What that is, what a composition platform is, and how it can help you to manage and operate your multi-tenant microservices, your SaaS applications, and packaged business capabilities, short PBCs, we will find out together in the next 45 minutes. This session is split into 2 parts. So the first part will be me talking about some general concepts, general guidance around SaaS applications. So we will be at a more outer level and have a view on SaaS applications, SaaS environments in general that apply to every customer out there. And then we will also cover a little bit of terminology, so talking about the difference between multi-tenancy and SaaS applications. And then we will have a transition over to Dennis, who will address a specific challenge in SaaS environments, namely, how do you introduce highly customizable components? So a fleet of highly customizable applications in a PaaS environment combined with a SaaS environment. So he will talk about Spryker's journey on AWS in the second part. So if you feel that the first part is a little too general for you, so the first 15 minutes, please stick with us. The second part will be more of a technical deep dive into the architecture of Spryker. This is a level 200 session, so we will not go into the AWS console. I will not show you any code snippets or a demo session here. This is a pure architectural session where we have a look at the architectural components of several AWS services. So with that, I would say, let's start right away. So let us start with the fundamentals of a SaaS environment. So we thought about there are tons of reference architectures out there that talk about SaaS environments for specific services, such as an EKS SaaS, a serverless SaaS, and these are great reference architectures. But we thought about what are the general building blocks that make up every SaaS environment. So what are the design patterns out there, and what are the building blocks that these design patterns fit into? And we came up with 3 building blocks that are part of every SaaS environment. So the first one is management. In a management building block, this is all about how you manage and operate your tenants. So we talk about metrics and analytics. So how you create tenant-aware metrics, how you create tier-aware metrics, how do you analyze them? And it doesn't matter which technology you use, Datadog, New Relic, CloudWatch. So it's more about the general concept behind it. The third part is the billing part. So how do you connect to billing providers? What is your billing concept? Do you use a pay-as-you-go model? Do you use a subscription model? Or a combination of both? And lastly, provisioning. So how do you provision and configure your infrastructure? What is your provisioning strategy? So a lot of parts here that you need to take into account when designing your infrastructure. The second building block is the application itself. So here we are talking about your multi-tenant microservices that you offer to your customers. So here we are talking about how do you isolate your workloads? How do you isolate data? Do you silo or pool your data? How do you partition your data? And on which level do you silo? Like, do you only silo on a compute level? Do you silo on a data level, or both? What is your deployment strategy? What are your deployment models, and what of them do you want to implement into your infrastructure? And lastly, routing. So networking is a big part of a multi-tenant environment. How do you route traffic for each request, you have to route the traffic to a tenant-specific workload. So you need to identify the region in the global infrastructure, and then you need to identify the tenant-specific workload and route traffic to it. How do you get a subdomain in this environment, and how do you route the traffic to the specific subdomain? And the third building block is tenancy. How do you onboard tenants? You need to register your tenant, and you need a stateful service that keeps track of the registration status. What do you do if it succeeds? What do you do if it fails? Then you need a tenant management. At some point, you need to introduce a tenant into your system. And then you need a user management. So at some point, you need to introduce users to your tenants. What identity provider you use doesn't matter. It doesn't matter which identity provider, it's just about the general concept behind it. Whether you use Cognito, Auth0, Okta, it doesn't matter. Just keep that in mind, that you need to introduce the users to your tenants. And lastly, tiering. You want to support different kinds of customer profiles in your multi-tenant SaaS environment. That means you want to offer a tiered experience to your customers. And now the major question is, out of all the design patterns that exist there, that fit into these building blocks, what combination, what flavor of these design patterns fit best to your needs? So fit best to your SaaS application. And then you ask all the right questions. You have to ask all the right questions to your business. What are my business goals? How do my SaaS application fit into these business goals? Do we have legacy considerations to keep in mind? Do we have compliance goals, compliance requirements that we have to keep in mind? So a lot of questions here, and most of them are business related and not technical related. Now let's go into how we actually build a SaaS application. When we build a SaaS application, we think about things like scalability, high availability, resiliency, cost efficiency. All of these things you might know from the well-architected framework. So for those of you who are not aware of the well-architected framework from AWS, I can highly recommend it. There are tons of documentation out there. These are great pillars. These are great pillars that fit to all the applications out there when you want to design an application in the cloud. But when it comes to SaaS applications, there is an additional layer of complexity that you have to take into account when designing your infrastructure and designing your application. Let's take availability, for example. In a traditional system, if your system fails, one or two departments or customers can't use the system. In a multi-tenant SaaS environment, when your system fails, entire businesses fail. That means the bar for availability in a SaaS environment is much higher compared to a traditional system because it is much more wide-sweeping and can cause chain reactions and so on. The second point is cost efficiency. So at some point in time, you want to achieve economies of scale in your SaaS environment. That's the reason why most customers even go into SaaS. So that means on the one side, you want to have high availability and design your infrastructure like that. But then on the other side, you want to have high available and a cost-efficient infrastructure. The third thing is predictability. This is hard to achieve in every IT system, but now consider a multi-tenant environment where you have an additional layer of complexity where tenants coming into your system, tenants leaving your system, and then you have tenant-specific workloads where traffic varies across the day, varies across the hour, varies across the month. So now you have to design an infrastructure that scales according to the traffic spikes that you have, but then is also flexible enough to handle the constant change on a tenant level. The fourth point are the deployment models. You have to use different deployment models in your SaaS environment. And that also means that you have a range of different deployment models and as a consequence thereof, different architectural concepts. In a normal, traditional environment, traditional system, you have one well-understood architectural concept for your solution. In a multi-tenant SaaS environment, you have multiple ones. So your IT team needs to support this and understand these. And lastly, the tiered experience. As I already said, there are different customer profiles or tiers out there that you want to support. Small businesses, medium-sized businesses, large enterprises. And for all of them, they have different requirements, different needs, so you want to offer different tiers, so a tiered experience to these customers. And that leads to some kind of a balancing act. Because on the one side, you have the business asking for maximum efficiency. You want to have just enough infrastructure that you offer to your customers. You want to have maximum cost efficiency and please share everything. Maximize the resource utilization. And then on the other side, you have the business asking for all the flexibility to offer a tiered experience, to offer a different deployment models to your customers. And now you have to decide on which level of the rope you pull and on which side. Let us now jump into the basic architecture of a SaaS environment. So this is the most outer level when you design a SaaS environment. And we call this the two halves of SaaS. On the one side, you have the control plane. The control plane pattern, I assume many of you are familiar with this. It's part of many technologies out there, Kubernetes, Kafka, and so on. So you have a central control plane that is responsible for managing and operating your cluster, and in this case, managing and operating your SaaS environment, so your tenants and the workloads within the tenants. Here are all the services that are part of centrally managing the cluster. So we have onboarding here, we have the billing process here, we have the monitoring here. And this gives you the huge advantage of having a separate set of services that can scale independently, that you can manage and operate independently and upgrade independently. And then on the other side, we have the application plane. Here live all your multi-tenant microservices and applications that you offer to your customers. Here you implement the isolation. Here you implement the data partitioning. Here you implement some parts of the monitoring process. And now, these two parts need to communicate with each other, because on the one side, you have the control plane that has to provision your application plane, and on the other side, you have the application plane that collects tenant-aware metrics and then sends these metrics back to the control plane. And in fact, you can also use different technologies for both planes. You can use, out of scalability reasons, you use serverless for your control plane. And on the other side, you use containers for your application plane. So this is totally up to you. And now let me emphasize a little bit on what SaaS actually means, because many people confuse it with that multi-tenancy and SaaS is the same thing. Let's assume that you already built your multi-tenant environment. You have multi-tenant microservices, where are isolated from each other. You have scalability in place. Everything scales independently. You don't have noisy neighbors. This is a great multi-tenant architecture, but it's not SaaS. In order to call it a SaaS environment, what is missing is the control plane. The control plane is the center of agility, scalability, and innovation within your cluster. So describing a SaaS environment with multi-tenancy is not enough. So we need a new terminology to describe SaaS. In fact, in a SaaS environment, you don't need multi-tenancy. Multi-tenancy just means sharing infrastructure. In a SaaS environment, you don't need to share infrastructure. In fact, lots of solutions have dedicated infrastructure for your tenants. Everything runs the same software. Everything runs the same solution at the same version. The infrastructure is just dedicated. And in this case, we call this a silo model. So it's still a SaaS environment, but you have a silo model. So in this case, an entire stack is dedicated to a tenant. Everything runs the same version, the same software. The infrastructure is just dedicated. And on the other side, you have the pool model. In the pool model, everything is shared. So the whole infrastructure, and still everything runs the same software and the same version and is controlled and managed and operated from the control plane. And then in between, you have the bridge model, what bridges the gap between the silo and the pool model that just emphasizes on the fact that you can have in one environment both the silo and the pool model. And you decide on which level do you pool, on which level do you silo. And now let me shortly transition over to Spryker's journey. So address a specific challenge in a SaaS environment. So imagine you're having your multi-tenant environment, your microservices. You have a control plane in place. Everything works seamlessly together. You have a tenant management, messaging in place. You have a service mesh for service-to-service communication. You have an application lifecycle. And now you want to introduce highly customizable components from your PaaS environment. So that means we now have two worlds. We have a SaaS environment. Everything runs the same version. Everything runs the same software. You have a control plane, and then you have your PaaS environment. How do you bridge the gap between these two worlds? And how do you do that if you don't have a few applications, but hundreds of them? And how do you do that if you have to do this on a global level, across multiple regions? And for this, I would like to hand over to Dennis.
Thank you, Stefan. Thank you very much. Thank you, Stefan. I hope that Stefan managed to raise your fear level to like that high with this diagram. And now we will try to unwind it, okay, to make it simple, to understand what problem we solve and how. But for that, we need to go into the very beginning of Spryker to understand the Spryker context. Spryker is a commerce vendor. We provide different solutions for building commerce systems. And at the beginning, we started with systems in B2C business vertical. We extended it with a B2B suite. We went into direct-to-consumers applications and projects. But now we also focus on marketplaces, so enterprise marketplaces, and power those companies that build challengers for Amazon.com. So if you are one of these companies, that might be an interesting talk with Spryker. But behind this business evolution, we actually had a technology. Underlying technology was also changing. If at the very beginning, 2015, we started with a just backend framework, focusing on developer experience, making the API development, business logic development right, we then extended it with multiple functionalities on the data exchange layer, on the API framework. We brought multiple frameworks into the game. We brought the front-end framework. And we called it Spryker Commerce Operating System because you actually could have all the tools that you need in the commerce environment to build commerce applications. And now we, after getting the application development right and after getting the developer experience right, we found that it's not enough to just build applications efficiently. You need to run them and operate efficiently. And that's why we brought Spryker Cloud, where you can build and run and operate your applications in a cost-efficient way. Then after we got multiple of these multiple business verticals covered with hundreds of customers' projects running up, we found that it's not enough for the cloud to just provide the cloud capabilities. We also need to have a place for our customers and partners to share their applications, to share their customizations, to share their business capabilities. And that they can be consumed and reused and recycled in different business scenarios. And that's how we brought Spryker Composition Platform to the game. To understand what is what is in general composition platform, we first need to look into term what is a composable application on itself. There is a terminology was coined by Gartner in recent years. The composable applications were going for quite some time, but Gartner actually called it packaged business capabilities, which is a way to define what, from business perspective, that means because the business user never understood what these composable applications are. But there are main characteristics that will across all of these applications, such as they must be modular, they must be replaceable, they must isolate their domain knowledge within them, and be independent capabilities, easily replaceable by other vendors, other business functionalities, such as flexibility and scalability. So when we are talking about one business suite consuming 5, 10, 15 of these applications, each of them must be flexible on the configuration and scalable on the technical throughput. It must be decentralized, that there is no shared or there is no one state of these applications, because it might be a PIM, it might be an order management system, it might be anything else, and there is no unified state. These applications might be decentralized. The last ones we learned in Spryker the hard way, that if you have a number of these applications, you also want that they very well come together. That these applications can notify, can be verbal about the internal business logic that is going on, that other applications can subscribe and react to that. And also they must be discoverable, because if there is no component discoverable, you can imagine it doesn't exist. So typically when you run a development team which runs one application, there is no communication problems. You might use integrations, you might call third-party system, but still you are focusing on one domain, and this is just fine, and you don't have connectivity problems or communication problems, except probably product managers fighting with the technical leader about technical requirements, right? But if you get at least a couple of these applications, you immediately start facing the connectivity problems between these two applications. How do they communicate with each other? What kind of API they provide? What resilience features and functionalities they provide if one application goes down? But it's still quite solvable issue if you have just two teams in your organization to manage that, because it's still one organization. But things start to get really complicated when you get many of those. If you have many different applications having distributed state that you need to manage somehow, that you need to debug, you want to understand how they all come together, how the end user business logic actually works, and in the end of the day, have an overview over deployments, over releases, how this development team can understand that their new release will not break all other applications in the composition that they present. And here we find that there is a missing component, but basically we want to have a system that will take over such challenges. And this is the composition platform. The composition platform itself, it's a place where different applications, where different business applications, their business functionalities and APIs come together, play well together, but also can respond to the challenges as the overall system or composed system would face, such as, again, resiliency, failovers, throughput, response time, scalability, and so on, and so on, and so on. Composition platform is taking over some of these challenges that developers don't need to solve them application per application, especially in the multi-vendor scenario, when we are talking about different applications from different companies coming together. They still need to have a standard that would be satisfied, that overall system will be still answering to the same, to the business challenges. So typically, composition platform takes over the application connectivity layer, unified developer experience, so you want that developers can release their functionalities freely and have a certain standards of quality of these applications, and state management and shared infrastructure, especially important for the asynchronous operations, where you throw event somewhere and how to ensure that another application got this event delivered. If each application would try to solve this problem by itself, your developers would only do this job. They would only figure out how to make sure that this message was consumed or got or taken by another application that is targeted. And another important piece is the application discoverability, where applications must be discoverable for business users on one side, but also for developers on the other side. Because if you want to build a more complicated business scenario, you would need to glue them together, and if application is not discoverable, it doesn't exist. So talking now about the platform. So generally speaking, there is now in the world, there is going the platform move. You can see many platforms coming up here and there in different industries. Again, like specifically in AI, in LLM, in cost efficiency, in clouds, and so on and so on. The thing is that it's much better described. I will not talk about this movement right now, but it's much better described in a great book by Gregor Hochpe called Platform Strategy. I can highly recommend you to look into the details how and why this is happening and how technologically we answer these challenges. But typically, if you are on the high level of maturity of your application, you would become a platform, you would want to become a platform, aggregating the ecosystem around you, or you would join one. Right? So understanding how these platforms are built, what kind of challenges they face, would help you to understand how to build a better software. So how to build a composition platform? So there are many challenges to solve with a composition platform, and we definitely won't cover all of them today. But if I would name 3 major challenges that if we solve, then composition platform does answer its targets. The first one is application connectivity. If composition platform can connect different applications coming from different business verticals, then this composition platform already starts solving developer problems and business user problems. Unified developer experience. When developers build their applications in local environments, how to make sure it comes all together in one unified composed system, that all the relevant systems are configured on time and relevant to the current system configuration as well. And of course, the quality gate. That every application that comes as a part of composition platform can respond to the same SLAs, to the same quality attributes that we assign to each application, to system overall. So let's start building them. First things first, there are a couple of patterns that I hope that you are already aware of, right? Like if you are talking about architecture, these are very common patterns that you would apply in the composable application world. It's a microservice architecture, this is event-driven architectures, and it's externalized configuration. Again, I will not cover these patterns in details. You have tons of videos and materials on them. But the last one, which is externalized configuration, it's the most simplest one from this, but most often forgotten by architects. But actually, what it means that your application doesn't know where it will be running. It's a development environment, it's a staging environment, or production environment. This pattern by itself, it enforces healthy development practices, but also good designs, good software design practices. So these 3 patterns, in my opinion, are major when you build composable applications. There is something ready to use, actually, even coming from AWS. And if you use in your composable environment, if you use a lot of infrastructure components, and if your applications leveraging only AWS infrastructure services like EKS, ECS, EC2, then Fargate, you can actually use App Mesh service that might connect and take connectivity problems out of your table and do the job for you. That's just enough. For Spryker case, when we want to elevate the application connectivity, not only infrastructure connectivity, but also application, the business logic connectivity, but also we want to make other cloud providers available for our partners and customers, we cannot go with just the solution. It would be too limited for our case. So that's why we went with our own composition platform. So in the first thing, on the connectivity, we would solve the synchronous operations. So on the left side, we have a consumer application, which might be a customer or client business logic, whatever it is. And on the right side, there is any of those SaaS, multi-tenant SaaS applications that provide their business logic and APIs for this client to be consumed. So the very simple answer, if you want to get a mapping between the API request and the application in the SaaS environment, it's the API gateway, right? It's exactly the purpose of the service, so let's just use it and get the mapping in the API gateway. API gateway here can detach the SaaS services from custom applications and make sure that in the future there might be other API version or other application that would serve to this business need or this business APIs. So the next problem to solve, it's asynchronous communication. And from first point of view, we could actually try to solve it the same way. We can say, okay, but why not just do the same mapping and the application would talk just to API gateway and the event will be propagated to other systems. But there is a problem with that actually, first of all, not one application will be a target for your client calls. There might be a number of applications that might want to hear out to the events of a client. And that means that we need to implement here observer pattern, which means that we need to allow certain applications to subscribe to events of other applications. And for that, we use already good enough service, which is a simple notification service from AWS that will take care of the routing of the receiving events, routing them among your applications, and this is already great. The thing that we discovered that SNS is actually quite limited on filtration and routing capabilities. So you cannot so simple run additional security rules, or you cannot extend it to a degree that it would take business logic also into consideration on what applications are allowed to talk to these applications, what applications won't be allowed. And this also doesn't work so well on the scale of thousands of the versions working simultaneously. And that's where we need to bring an additional storage where we actually will store additional configuration rules for the SNS and the Lambda function. The only role for this Lambda function is to take in a type of event, understanding what kind of routing rules, additional configuration routing rules are needed for distribution of this event, and passing it further to SNS to actually distribute with this additional configuration. Right? Very simple, very designed solution that already solves a very complicated event distribution and security control task. The next one, of course, we want to talk backwards, right? So once we talked from a client side to the SaaS applications, consuming business functionalities, sometimes your SaaS applications want to talk to your client applications, to the consumer of these APIs. For example, PIM system might change price or product information and might raise a flag that actually product is updated. Please update your storefront. Please update your API. Please update your application and do the necessary event changes. Luckily that we already have all the components in place and we just use the same architecture. So we would hit the API gateway. For this purpose, the Lambda function would get additional configuration from the dynamic database, and then through an SNS would distribute over the application subscribed to this type of events. We use DynamoDB, however, you can use any document storage. It really doesn't matter. It's just additional configuration that you want to provide. It's really based on what types of complexity for type of events you have. That's it. The curious eye can also find that we have only asynchronous communication going backwards, but there is no synchronous communication going backwards. There is actually a reason for that. The reason is for that typically from consumer side or from the SaaS application side, so you cannot expect any APIs or any specific logic on the consumer side because it might be none. There might be no APIs, there might be no entry points, and this application actually is not necessary, will be available on time for you for synchronous operations, right? That's why this type of operations is forbidden by design of these type of systems. So the next one, it's developer experience. So if you would look into developer experience, we need to solve a number of problems now, right? We have so many systems there to configure every time a new application comes to game. How to make sure developers are not overwhelmed, solving these problems again and again for each release. So for that, we have now a number of systems, of course, like API gateway, like SNS, and in this case, RDS for application catalog. That might be actually anything on your taste. Basically, it's a way to provide the API catalogs together to the end users or developers that would see it as a catalog of services or APIs that you have, right? In the end of the day, it might be not RDS with a nice UI, as we have at Spryker. It might be just a Swagger documentation, right? That describing what kind of capabilities I am as a developer or as a business user do I have and can consume. So for that, we have a very simple approach here. So we created a configuration Lambda function that only does configuration of the internal composition platform services that are necessary to make the APIs available to the end user. That's, again, registering these such API sets in the API gateway, propagating the events types and event documentation into SNS together with routes, and making this application available. So now what basically happens if a PIM gets a new version, let's say we develop a new version of PIM and we are now releasing, when on the moment of release, PIM would just throw a new event that, look, I'm of a new version now, and this is a new set of APIs that I have, and this is a new set of events that I can provide now from this version. Then this configuration Lambda just takes over this event and distributes the configuration over necessary systems within AWS. Why is it a simple solution? That AWS has a really good connectivity with Lambda functions and internal services. So we can just do their configuration with calling their internal APIs without leaving AWS VPC or AWS space, which is great. It's also, on one side, it's fast. On the other side, it's cheap. So once we solve by doing that, basically now developers don't care, are they building just a PIM system with some APIs, or they are publishing it on the composition platform to become a part of a bigger composition in the future. They just need to satisfy these rules and throw the necessary events that again described by composition platforms, and they don't care about no wiring, no API updates, everything happens automatically, and that's what we need. So talking about the quality gate, and this is the last biggest part of the composition platform, it's to make sure that whatever comes, every component and application coming to composition platform, it actually offers standards and the quality that we expect. There is a number of rules that we would validate. It's of course code quality, it's business quality, but it's also API quality, compatibility to the infrastructures that we provide. In Spryker case, we use a very simple system. We use code pipelines for that. But actually, it might be any CI system. It doesn't really matter. But what we really want to validate, this is even more important. We want to validate the app metadata. We want to know what this application, how is it called, what the version of this application is right now coming to our space, and how to find it. On the API mapping, we want to understand what kind of APIs are available and what events, types, and structures are available, because they will be later documented as a part of composition platform. We want to validate the code quality when it's possible. For third-party applications, of course, it's not possible. But for applications leveraging Spryker frameworks to build these applications, we actually validate that code quality of following Spryker standards. Documentation is a big beast, right? But what we want to make sure that every application coming to this platform actually has a piece of documentation describing this release. And as you know, when you have more than 3 applications, it's very hard to keep track for the consumers, for developers who will consume these APIs, for all the applications and functionalities that are coming on your platform. So there is a special validation for that. We do also apply performance testing in isolated artificial scenarios where we take application, and during the quality gate, we actually run different performance test cases based on the API mapping that was provided. Again, you probably know how much performance and scalability is important in e-commerce, so we want to validate that it's not only composition overall is fast, but every particular application is following our standards, at least on primitive level. Of course, we cannot validate every single case and configuration of application, but very simple ones, we can just use a Swagger API and event API description to get them tested. And security testing, SAST and DAST validation, big thanks to our partners, Snyk, who support us with that, with these validations, but we also want to make sure that APIs are used also in the secure and well-configured way. So now we have all components together. Now let's look into real case scenario, how the architecture of Spryker composition platform looks like. So this is first quite a scary diagram, right? But the good news is that you actually already learned all the components of it, and you know most of this. So on the left side, you can find the consumer application that is a custom application built on top of the composition platform and consuming APIs. On the right side, there is a multi-tenant SaaS application that provides the business capabilities and APIs. And in the center, you can find the composition platform itself. Composition platform is dropped down to multiple subsystems, which is you can find already known sync API router, asynchronous event or event router. You can find the connection service that is taking responsibility for keeping track of connection, what consumer asks for what applications, and backwards, what applications want to know which consumers when they initiate a connection. Configuration service, it's about fleet configuration when we have information that should be provided as a configuration to each application, or an application want to notify, I am ready, please register me with a new version of API to your application catalog. An application tenant registry service, which is the application catalog, just an overview, what do we have, right? In the end of the day, it can have a business interface, like a nice UI with a catalog of applications, but on other sides, it might be just Swagger documentation, that's it. And number of shared services. When we have that architecture, we also want to make sure that its actions are logged. We can debug the process. We can also understand if something is going wrong, but also we can store secrets of all of these applications in a secure and predictable manner. So here, the simple flow here is from the left side. So all of these flows that we discussed before are also drafted here. But in the simple terms, a consumer application might throw event to event router that will be taken by API gateway. With the help of Lambda function to get configuration from DynamoDB, it will be distributed by SNS service by multiple of SNS SQS services or applications on the right side. So that's basically it. What I want to, again, this is complicated, quite complicated dive. There's still a lot to do with platforms, and I wanted to give you a glimpse to what platforms, or what connectivity problems and challenges we are solving now when we get all of your beautiful applications to work together for one single customer, right? That's why you can also now start thinking from this prism how to become a part of a bigger solution, how your applications should behave and what it should respond to if you want to become a part of a large enterprise project, right? All of these problems appear on every enterprise B2B or marketplace or other customer projects that we see. However, there are a few things that I want to emphasize. This solution won't be possible if you would start building from scratch and building ourselves, right? So most of these components are actually reused from existing ones. We use a lot of open source. I didn't mention many of projects and libraries that we use right now. Again, we have an emphasis on the number of AWS services that we use today, but actually, it's dozens of services that came together, and our job was to glue them correctly. So if you are up to build custom software, so again, try to find a library that already does it. Next one is that AWS service catalogs is actually larger than we think about it. So every time when we build something super custom, we reach out to Stefan and Stefan's team, and we found there is something already existing on AWS side that we can really reuse and have a result tomorrow instead of in 3 months, which is great, right? And the third one, it's probably one of the most important. It's like if I would set one thought for today, it's if you build in custom, it doesn't yet mean that you are let alone to deal with that. Every time when we now engineer in the really post-coding era, where most of components that come to your mind already built in open source community or by a specific vendor. And every time you start using them, you actually join a community. And when you join a community, be a good community member. Share your feedback, share your issues. And I'm specifically talking when with the paid vendors, you actually have this relationship by nature, right? If you paid for service, you will give them all feedback you had on them, right? But talking about open source community, again, use your chance, share your feedback, raise your issues, share your customizations, reach out to developers. It really helps to push the boundaries of innovation. And the platforms like that, and even more complicated in the future, will be possible to realize. Thank you.
Yeah, also, thanks from my side and for listening. I hope you got some great insights here also. Thanks to you, Dennis, for sharing these insights. Thanks a lot. Have a nice REST Summit.
Thank you very much. See you later.